Good afternoon to all. Is the screen visible, everyone?
Yes, sir.
Yes, sir.
Yes. So what we have started in the last class? In the last class, we have started with work, energy, power. Okay. You know what is work, what is the energy, and what is power. What is the unit of power?
Watt.
Newton meter per second. That is also called as 1 watt. What is one British horsepower? How much is the one British horsepower? One British horsepower is equal to 745.8 watt. One metric horsepower is equal to 735.75 watt. What is the work energy principle? What is work energy principle? Principle of work energy equation.
Kinetic energy.
Statement is what? What is the statement for work energy principle? Yes, resultant force into displacement is equal to change in kinetic energy. Okay, that is the work energy equation. So we have solved two problems. Correct? What was the last problem? Three problems we have solved. Yeah, try करते हो गए ना? Yes, okay, fine. Check on this problem. A block weighing a block weighing 2500 Newton, 2500 Newton, rests on a level, rests on a level horizontal plane, horizontal plane for which coefficient of friction, for which coefficient of friction, coefficient of friction is 0.2, 0.2. This block is pulled by, this block is pulled by a force of 1000 Newton, a force of 1000 Newton acting at an angle of acting at an angle of 30 degree to horizontal, 30 degree to horizontal. Find the velocity of the block. Find the velocity of the block. Find the velocity of the block after it moves 30 meter. After it moves 30 meter, starting from rest. Starting from rest. If the force of 1000 Newton is, if the force of 1000 Newton is then removed, how much further will it move? Further will it move? Will it move? Stop. Question mark. Use work energy principle. Use work energy principle. this is the problem. A block weighing 1500 Newton. Okay, so there is a block. Its weight is 1500 Newton. Okay, then the coefficient of friction is given F. A block, this block is pulled by a force of 1000 Newton acting at an angle of 30 degree with horizontal. So there is a force which is applied and it is moving at an angle of 30 degree with respect to horizontal. Okay, the P is acting. Weight is acting downward direction. Okay, then find the velocity of the block after it moves a 30 meter starting from the rest. If the block is 1000, okay, this is the first case, weight is acting downward. In the second case also weight is acting downward, but this P is removed now. Okay, now it is more. So the block is resting initially on the ground. Whether the ground is smooth or hard, rough or smooth, it is rough. Okay, friction, it means it is a rough ground. So this is the ground. Okay, so its weight is how much? 2500 Newton. 2500 Newton. A 1000 Newton force is applied. 1000 Newton force is applied at an angle of 30 degree with the horizontal. Okay, so after moving at a distance of how much it is? 30 meter. 30 meter, the 1000 Newton is removed and it will go and it will rest after some time. Okay, what he is asking, if the force of 1000 Newton is removed, how much further it will move? So initially इधर से इधर आने के बाद कितना हो गया डिस्टेंस? 30 मीटर आ गया. 30 मीटर आने के बाद the 1000 Newton is removed, then again further how much it is moving. So this is how much. Yes, this is how much. Okay, then use work energy principle. Is it understood, everyone? Okay, when the body is moving in this direction, how will the frictional force? In the opposite direction? Okay, so I will take this is opposite direction, this is the frictional force. Now, after removing this 1000 Newton, the body is moving in the same direction. Okay, but the motion is reducing, and finally it will come to the rest. Okay, how will be the friction? Same direction? Okay, so this is also rough. Good. Wait, what is the weight? 2500 Newton. Okay, okay. Solution. Friction is given. Coefficient of friction. What is that? Mu is equal to 0.2. Okay. When the I will take this 1000 Newton is as P. Okay, P is applied. So solution. When full P acting, when full P is acting. Aware. When P is acting. Okay, see, this is a rough ground. If there is a rough ground, there is normal reaction. Okay, and this is also there is a normal reaction. Yes, I will take this is N. Okay, so this is N. There is a friction. Yeah, this is a friction. Yeah. Okay, when pull P is applied or acting, what is the normal reaction? N is equal to. Can you tell me what is summation of forces? I will take summation of forces. So summation of forces parallel to plane, correct? Parallel to plane. Parallel to plane. Yes, is it audible? All of you?
Yes, sir.
Yes, sir.
Yes, yes. Forces parallel to the plane is equal to 0. Now tell me, from the first figure, what are the forces which are parallel to the sorry.
Minus
Normal.
zero.
First write on the normal. Because n find out करने के बाद f find कर सकते हैं. Okay. Instead of forces parallel to the plane, I will take forces normal to the plane. Forces normal to the plane is equal to 0. Okay. So yes, n is moving upward direction plus n. Weight is the acting downward minus 2500. Then P is acting at an angle of 30 degree with respect to horizontal. Then what is its vertical component? Yes, P is sin 30. So can I take it is plus 1000 sin 30 degree? Yes. Is there any other forces which are moving in the vertical direction? No. So it is equal to 0. So determine the value of n. So it is 2500 plus minus 1000. Sin 30 is 1 by 2. So 500, it is 2000. N is equal to 2000 Newton. Is it correct, all of you?
Yes, sir.
Yes. Okay, good. Then once if we find out the value of n, then what you have to find out? You have to find out the value first
Yeah.
F. Then again you have to find out the value of force, summation of forces. So first I will take the F value. Okay. From which law? From laws of friction. Friction. F is equal to mu into N. Correct? So F mu is given 0.2 into 2000. 2000. That is equal to 400 Newton. Okay. You got F,
Yes.
you got N. Now which equation will you apply? So initial velocity is okay. Which equation apply करने के लिए उन्होंने बोला? He is telling to apply the work energy equation. So in order to apply the work energy equation, total resultant force चाहिए. Okay, in the direction of displacement. How the displacement is moving or occurring? Motion is occurring in the horizontal direction. Okay, summation of all the forces moving in the right or horizontal direction. That is nothing but forces, the set of forces. Multiply by what is the distance? 30 meters is distance. Okay, so what is initial velocity? Initial velocity. It is equal to 0. U is equal to 0 because he has given it moves 30 meters starting from the rest. Okay, rest is 0. Okay, so let final velocity be. Let final velocity be v. Okay, next displacement is given. How much? Displacement is equal to S is equal to 30 meter. 30 meter. 30 meter. Okay. Next, apply work energy equation. Apply work energy equation in horizontal direction. In horizontal direction. Horizontal direction. Horizontal direction. Okay, what is in horizontal direction? Net forces in horizontal direction. P cos 30. Okay, plus 1000 cos 30. Then friction moving opposite direction minus how much it is friction? 400. Then is there any other forces which are moving in the horizontal direction? No. So you will get into S. Into S. What is S? S is equal to 30 meter. Okay. This is equal to okay. Half. Before writing this one, I will write the in general formula. So what is the in general formula? For this case, P cos 30 minus friction into S. Into S is equal to half M final V square minus initial V square. Is this correct? Correct, Anna? Yes. Next, half. What is M? W by G. What is the W? W is equal to 2500 divided by 9.81 into what is the final velocity? 30. Now, in this case, V 30 by V is the final velocity, right? V square minus initial velocity is 0. So find out the value of V first. Find out the value of V. See, to come from this point to this point आने के लिए this is the velocity है. इधर आने के बाद क्या हो गया? This P is removed. Now for the next case, this is the initial velocity. Calculate what is the value of V. Yes, correct. It is 10.47475. 474 meter per second. See, all of you concentrate. So what is given? There is a block. Okay, the sulfate is given. Then there is a P force is applied at an angle of 30 degree and it is moving in the horizontal direction. After 30 minutes, after 30 meter, the P force is removed. Okay, initially rest में था body. Now to come at a distance of 30 meter, it has occurred a velocity 10.47 meter per second. Then after reaching 30 meter, the P force is removed. Now for the second case, what is the initial velocity?
0.
Yes. Yeah, what is that one? See, once again I am explaining it. Once again I am explaining. Listen to me carefully. Initially, the body was rest. Okay. Now it is moving. After reaching a 30-meter distance, the body is getting final velocity is 10.47. Okay. Now the body, the P force is removed after reaching 30-meter. Now what is the initial velocity? 10.47 is the initial velocity. Then what is the final velocity? Zero, because after removing the P force, the body goes to rest. The final velocity is zero. Then what he is asking? What is the S value? When the body comes to the rest, what is the distance? He is asking. Okay, you have to apply the same work energy equation for the second case. Huh? No, why you are applying that one? Same work energy equation you have to apply. Yes, wait. So for the second case, for second case, what is that second case? What is that second? If P is equal to 1000 Newton is removed, correct? Is removed. Let the distance moved. Let the distance moved BS. Before the body comes to the rest. Before the body comes to rest. Correct? Then initial velocity is how much? Initial
10.4.
velocity. Yes, that is U is equal to 10.475 meter per second. Then final velocity. Final velocity is V is equal to 0. Next, how will you apply the? Okay, now you apply the work energy equation. So in the horizontal direction. Okay, what are the forces moving in the horizontal direction? Now you have to apply. Apply work energy equation. Work energy equation. Okay, what are the forces? Okay, minus F. Okay, correct now, minus F. Because displacement is in the right direction, but force is applying in the negative direction. So minus F into S is equal to minus F into S is equal to half M V square minus C square. Yes. What is the friction? Minus F is how much? 400 into S. You have to determine half M is equal to W by G. 2500 divided by 9.81 minus into the bracket final velocity is 0 minus initial velocity is equal to 10.475 square. So calculate the value of S. This is the answer. This carries 8 marks in your offline paper. University paper, it is 8 marks question. 8 marks. Okay. Yes. Write down now. Yes, you will get 27.96. Yes, correct. 27.96 meter. Okay. Understood? It is. Is it understood?
Yes.
Is it understood? Yes. Yes. Fine. Okay. Write down. I have uploaded all the assignments. Assignments, I think 6 and 7 is not uploaded. And I have uploaded all the notes. Okay, have you checked teaching diary? Yes. Okay. Even chapter number 7, 8 notes also uploaded. And I have uploaded the MCQs also. Check it. MCQ also I have uploaded. Tomorrow is ISN. आज से चालू है ना? Unit. It's completed. Yes, is it completed? See, in this problem chapter, all the problems are same only. There is a from one point to another point. It is started from rest, or it may be started from some initial velocity. You have to find out the final velocity, or you have to find out the displacement कितना हो गया. Okay, from the second case, second body to next, velocity. Okay, you have to find out only velocity or displacement. This is the only problem. Again, there are two more problems are there, same, but you should know the concept. But you have to apply the work energy principle. Okay, that is important. Completed? You should know how to draw the free body diagram. See, the free body diagram concept we have learned in the first chapter or second chapter, correct? Na? Equilibrium of forces. So from that point to till now we are studying the free body diagram. Yes. See, whatever you are studying in the frames chapter, beams, if you start here, it will end till your last breath of life. Because in the civil engineering, beam design करना है तो road आपके reaction support of road civil engineering, we have to remember that one. Support reaction. Okay, सभी का? Yes, Kunal. Is it over?
Yes, sir.
Can I go for next slide? Yes, roll number 2, 3, 6, 7.
Yes, sir. Yes, sir.
हो गए ना? Okay, okay.
Yes, sir.
Okay. Let us next problem. This is also important. See, whatever problems I am solving, these all are important problems from the university question papers. Okay. So next question. A block of 5 kg. A block of 5 kg mass slides down inclined in an inclined plane from rest. How far along the horizontal plane will it move, will it reach before coming to rest. Question. The coefficient of kinetic friction. The coefficient of kinetic friction. Kinetic friction. Kinetic friction between the block. Between the block and inclined plane. Inclined plane is 0.15 and that between the block and horizontal plane is 0.2. Okay, so this is the problem and he has given the figure also. Draw this figure. This is a A point, this is a B point, and this is a C point. Okay, what he is saying, a block of weight 5 kg है. Its mass slides down an inclined plane from the rest. So initially it is rest. Okay, then the inclined plane is having a 30 degree. This is 30-degree inclined plane. Say here the body is moving from initially from the rest. Okay, it is coming down. Okay, so after coming at the point B, whether is it in the rest position at B, is it in the rest or it is in the under motion only? See, from A it is started. From A it is started. When it comes to the B, it will reaches the horizontal plane, but its motion is not zero. Okay, it is having some energy. So here the initial velocity is equal to 0. You have to find out the final velocity at this point. Okay, then that will be the initial velocity for the horizontal plane. Okay, then this will be the initial velocity for the horizontal plane. Then again you have to find out the final velocity. Final velocity is equal to 0. But how much is the distance is asking? Okay, this distance is given. This is 4 meters. This inclined distance is given 4 meters. He has given angle also 30 degrees given, 4 meters is also given. Okay, so first what you have to do, you have to draw the free body diagram of the both cases. Okay, so first I will draw the free body diagram of first and second cases. Okay, now help me. So how to draw the free body diagram? Yes, from the A body. So I will take A. So this is the body which is there. Correct? Yes. So what are the forces which are acting on this body? Weight is acting downward direction. Okay. Then plane is body is moving in this direction, downward direction. How will the friction force? This is the friction force. Then there is a normal reaction. Okay. Then this body is making an angle of how much? 30 degrees with respect to vertical. Okay. This angle is 30 degrees. Is it correct? Yes. What is the weight? Weight of the body is W, and this is a frictional force. This is a normal reaction. Okay. Then is there any forces? I will take this is N1. This is F1. because for the second case he has given alag friction coefficient of friction. He is not given the same. See, for the inclined plane, the coefficient of friction is 0.15. For the horizontal plane, the coefficient of friction is 0.2. So इसके लिए I will take different F1 and F1. Then for the second cases, so what are the forces which are acting on the body? Weight is acting downward direction. Then how the body is moving? It is in the right direction. Okay. Then how will be the frictional force? Left direction. How will be the normal direction? Okay. This is. And is there any other forces? No. So what are the things? This is the W. Then this is the F2. This is N2. Correct? Huh? So now you can write down. This is FBD. FBD. Consider FBD. Is it understanding all of you?
Yes, sir.
Consider FBD of block on the inclined plane on inclined plane at A point at A. So summation of forces. How to find out the unknown? Summation of forces moving parallel or normal? Normal to the plane. Plane. This B is equal to 0. Okay. Now first figure, what are the forces normal to the plane? N1 moving upward direction. Then weight is moving downward direction. Minus what is the component of weight? Yes. Minus W cos 30. Yes. Is there any other forces which are moving in the upward direction? N1 is equal to how much? W is how much? W is equal to how much is 5 kg is given. Okay, 5 into cos 30. Cos 30. How much it is? 4.33 kg. Okay, he has given kg. You have to be very careful. Okay, next, how to find out the F1? F1 is equal to nu times of N1. Okay, what is the value of nu for the inclined plane? 0.15 into N1 is 4.33 k. Okay, so what is the value of F1?
0.64.
F1 is equal to 0.64. 0.64. Okay, kg. Correct? Yes. Next, apply work energy equation from A to B. Apply work energy equation from A to B. A to B. Yes, apply. A to B motion. Yes, body is moving in the inclined plane downward. It means summation of forces normal to the parallel to the forces. So what are the parallel forces? In the downward direction. F1 is moving
Minus
upward direction or minus F1. Then weight is acting plus W sin theta. Okay, so I will take sin theta into S is equal to next half mv square. Okay, you can take mv or W by 2 G into V B square minus VA square. Can I write velocity at a final velocity means at B? Velocity at B square minus velocity at A square. Yes, calculate minus F is equal to minus 0.64 plus W is equal to 5 sin 30 into S is how much? S is 4 in the given in the problem is equal to W. Okay. See what is given? Mass. Mass is given or? Yes, mass is given. Okay, read on. So I want W. So how to convert that W into mass into W? 5 is mass into 9.81 into 9.81 divided by 9.81 get cancelled. So half mv square directly लिख सकते थे. Okay, so these two get cancelled. Okay, VB is I have to determine VB square minus VA square. VA square कितना है? 0. What is the value of VB? Actually, I am having a doubt whether it is IU, kg or Newton. Okay, Newton होने चाहिए. So I will check it. Okay? I will check it. So just take this as a Newton. Wait, I will check it.
1.72.
No, wait a minute. So you just take it as a Newton to and solve it. Okay, I will check it once again. You take it as a 5 Newton. 5 Newton. So this will be Newton. Then this will be Newton. So next, now it is also Newton. Consider this is 5 by 2, 9.81. Consider this is Newton and solve it. I will check it. So 5 is W divided by 2 into 9.8. Yes, check it. What is the VB? No. Okay, square root करने का root of answer. Check it.
$5.40.
Yes, correct. Is 5.40 meter per second. Okay, so this is the VB point. So now what he is asking? He is asking the distance in the horizontal direction. Correct? So how to solve this one? For the motion in a horizontal plane. For what is the answer? Okay. Next, for the second case, for motion in horizontal plane. Okay, horizontal plane. So consider FBD of the block. Consider FBD of block in figure B. In figure B. Okay. Next. Now, what is the initial velocity? Now it is very, very important. Initial velocity. Velocity is equal to 5.4. Okay, 4 meter per second. So I will take this is VB. Correct? Next, what is the final velocity? Final velocity is equal to 0. That is equal to V at C. Okay, so apply work energy equation. Yes, apply work energy equation. Yes, so I'll write here only. Apply. What is the work energy equation? In the horizontal direction. So you should find out the first फ्रिक्शन निकालने का. पहले हम न्यू n2 निकालने का पहले. So what is the value of n2? So what is the value of n2? n2 is equal to same as that of w. That is equal to 5 kg or 5 Newton. Correct. Then f2 is equal to mu times of n2. mu2 into n2. Yes. mu2 is given 0.2 into 5. That is equal to 1 Newton. Okay. Then now apply work energy principle. Work energy principle. Work energy principle. Tell me how the F is moving, how the displacement body is moving. F is in left direction, body is moving right direction. So minus F into S minus F2 into S. Correct? This is equal to half mv square. Okay, I will take it is W by G into V at C square minus V at B square. Correct? All of you. Minus F2. What is F? 1. I want to determine the value of S. Half. What is weight? Weight is equal to 5. Okay, 5 Newton divided by 9.81 into V at C is how much? V at C is 0 minus V at B is how much? It is 5.4. 5.4 square. Okay, calculate the value of S. Yes, this is what he is asking. all the problems are same only, but the thing is you have to apply the free body diagram and carefully you have to apply all the concepts. Yes, correct. 7.4 meter. Okay, this is the answer. Understood, everyone? Yes. Yes.
Yes.
Get it.
Sir,
Ah. Yes. Tell me.
sir, body का weight 5
Now body का weight.
न्यूटन लेना है क्या?
हाँ 5 न्यूटन ले. ओके आई विल चेक वो 5 केजी है क्या 5 न्यूटन. अभी 5 न्यूटन लेके हमने सॉल्व कर रहे हैं. ओके
ओके
क्योंकि सभी प्रॉब्लम्स इन टर्म्स ऑफ न्यूटन में ही रहे.
ओके सर.
ओके roll number 9 present. Roll number 11 13 13 15 16 18 19 20 24 29 34 38 who is 38 38 who is roll number 51 51 are you there? What is your name? Only roll number is written G51. What is your number? Name. If you don't reply, I will put you as absent. 51. आया था क्या? 52. 52. 53. 53. 61. Okay. Absent numbers 13, 16, 18, 19, 34, 53. Okay. Is it completed?
No, sir.
Oh, okay, okay. I will give one problem as a homework. Will you do? We'll see. If time permits, I will solve. Or else we are- ऐसे एक प्रॉब्लम चाहिए. ऑलमोस्ट ऑल प्रॉब्लम्स है सॉल्व. और एक प्रॉब्लम है ये. दिस इज आल्सो फ्रॉम द यूनिवर्सिटी क्वेश्चन. ओके आई विल गिव इट एज होमवर्क. हिंट्स हिंट्स भी नहीं चाहिए क्या? हाँ ठीक है. कंप्लीट इट फर्स्ट. Still, I need minimum 2 lectures to complete this one. 2 plus 2, 4 lectures I want. Not so. इसके लिए 4 चाहिए. In fact, yes, completed. अभी वो सुनने के लिए टाइम नहीं है हमारे पास. इतना बिजी हो गया. अभी भी बिजी है. Just completed. समझ में आ रही है ना प्रॉब्लम? See, drawing the free body diagram is very, very important. Is completed all of you?
Yes, sir.
Yes, sir.
Yes,
All
sir.
of you?
Complete.
Yes.
Yes, sir.
Can I go for next point? I will. There is
Yes,
one.
sir.
I will give the problem as a homework. Okay. All of you how to please try. Okay, right on. Determine a constant force P. Determine the constant force P that will give the system of bodies, at bodies as shown in figure, a velocity of 3 meter per second, after moving 4.5 meter, after moving 4.5 meter from the rest, take mu is equal to 0.3 and pulleys are smooth. Okay. So this is the problem given. So for this problem, there is a diagram is given in the problem. So this is 500 Newton. 500 Newton. The force P is applied. This is 2000 Newton body. 2000 Newton. This is 1000 Newton. 1000 Newton. The ratio of this one is given. So P is 4:3. 4:3. This is the rough plane. Okay. He has given coefficient of friction. Then there is a force P is applied. You have to determine this value of P. This value of P you have to determine. Huh? First 500 Newton. So this is 500 Newton body. This is 2000. This is 1000 Newton. Okay. Determine the constant force P that will give the system of bodies at the as shown in the figure. Velocity of 3 meter per second after moving the 4.5 meter. Okay. Then from the rest, initial velocity is 0. Final velocity is 4. That is 3 meter per second. Okay. Distance is given 4.5 to determine the velocity. Will you try or I need to solve? Try करते
ट्राय करतो सर.
Yes. Try करिए. If answer चाहिए क्या?
Yes.
Yes, sir.
Okay, I will give the answer. Okay. So P value, final value P is equal to 2766 2766.77 kilonewton. This is the value. You try करें. So in case if you don't get, I will solve this in the next class. Okay.
Yes, sir.
Yes. Have you written? Okay. Next concept. Still 5 minutes, na? I will take only 5. Only definition I will take. Only 5. Still 4 math. No. अभी मैं लिख रहे ना. Okay, right on. Only 5 minutes. Impulse momentum. Only 5 minutes. Impulse momentum. Can you tell me what is impulse? In your science, you have learned. Pendulum. Okay. What is impulse force? Have you heard impulse force? A large force acting in a short interval of time is called as impulse force. Kicking the cricket ball. Large force is acting in a short interval of time. Blasting an atom bomb. So large force is releasing in a short interval of time. That is an example for the impulse force. Okay. Okay. So first write down linear impulse and momentum. Linear impulse and momentum. If R is the resultant force, acting on a body of mass m, then from Newton's second law, Newton's second law. Yes, can you tell me if a body is subjected by a force R, okay, and of mass m, then what is Newton's second law? It is here. It is not F. It is R is equal to m into A. Is it correct? But what is acceleration? Acceleration is equal to A is equal to dV by dt. Yes, dV by dt. Then so this means R is equal to m into dV by dt. Yes. Here I want to find out the value of total R. So can I write this is R into dt? R into dt is equal to m into dV. So can I write this one as integration of R into dt is equal to integration of m into dV? Okay. Okay. Here, if the initial velocity is u, if initial velocity कितना है? U. Initial velocity is u, and after time interval t, it becomes what it becomes? It becomes initial velocity is u. After some time t, it will become final velocity. What is final velocity? V. So it becomes V. It becomes V. Then initially time is 0. After some time it is t. So can I write this integration as 0 to t into r into dt is equal to 0, it is u to v into m into dv. Is it correct? Okay, integrate this one. So
Yes,
this
sir.
one is equal to m into integration of dv is equal to, it is v, finally v minus u. Is it correct? All of you. So can I write this one as m into v minus m into u? Yes. So this entire term is called as, okay, right on. Therefore, integration of r into dt from 0 to t is called impulse. Is called impulse. Unit is unit. What is r? Newton. What is dt? Second. Unit is Newton second. A large force acting in a short interval of time. That is nothing but impulse. Newton second. Then the term mass into velocity. The term mass into velocity. Velocity is called as. Do you remember what it is called as? Mass into velocity. Momentum. Momentum. We have learned in the first chapter, correct? Therefore,
Yes, sir.
now, so m into v, mass into velocity, momentum m into v. So this can be written as m is nothing but w by g into v. What is the w by g? That is Newton into second. Newton second. So therefore, so here, what is this right hand side? Left hand side. It is impulse. Impulse is equal to, what is this one? M into v is final momentum. So what is this? M into u? It is initial momentum. So impulse is equal to final momentum minus initial momentum. Okay, this one you have to remember. In order to solve the problem, this formula you should remember. Okay. Write on this much. So remaining things we'll write in the next class. There's impulse momentum equation is there, and based on this impulse momentum, there are some problems. Okay. So this will, now I will stop now. So please take the screenshot. Okay, I will stop now. Have you taken screenshot?
Yes, sir.
Yes, please take the screenshot. I will stop sharing. Notebook. Tomorrow I will check. Wait, आता है क्या? कल पे किया ना? Yes, have you taken photo? Yes, I will stop now. Okay, thank you all.